Air-breathing jet engines, which are also called duct engines, are very often used in aircraft. The first plane in the world that were driven by a jet engine is the Heinkel HE-178 at the end of the 1930s. The engine was placed at the level of the wings. The air entered through the nose in the front, was then directed to the engine, was burned, and left the aircraft through the tail. Because engines still work today according to that principle, let's examine the engine of the HE-178 and its working principle. First, the engine has an axial compressor, which compresses the air that flows parallel to the axle. A centrifugal compressor is placed behind it. It compresses the air to the outside. An air diversion is placed in line, making sure that the air flows in the right direction into the combustion chamber. The fuel is injected in the combustion chamber and burned. At first, this is achieved with igniter plugs, but once running, the engine only requires an input of fuel to maintain a self-sustaining combustion cycle. The combustion leads to a rise in temperature and an increased speed of the gas flow. The turbine is set in motion and drives both compressors. Finally, the exhaust gases leave the airplane in a fast-moving stream. This produces thrust. Such a jet engine is called turbojet and was often used until the 1960s. Today, we mostly use turbofans, also referred to as fan jets. In the front part of the turbofan, which is shown here, are 3 rotating compressor wheels, which are often called fan. Not only they suck in a great amount of air, but they also start compressing the air sucked in. Stadders are installed between them, which are firmly attached to the nacelle. Only 2 stadders are represented here, but usually there is a stadder after each rotor. This is also the case for the other compressors, which are installed in the core of the engine. 4 turbines are placed at the other end of the engine. The fan is installed on a shaft with 2 turbines. In the core of the engine, the compressors are on their own shaft with 2 turbines so that they can rotate faster than the fan. Fuel, usually kerosene, arrives in the combustion chamber through a fuel injection system. Now, let's take a closer look at the entire process. The air is sucked in from the front into the turbine by the blades of the rotors, accelerated and compressed thanks to the stators. The air is then divided into a bypass airflow, marked in blue, and a core flow, marked in red. The bypass airflow goes past the core engine and is not used for the combustion of the fuel. The rotating fan accelerates the bypass airflow, which creates a strong thrust at the exit of the engine. The core flow is used for the combustion of the fuel, which drives the 4 turbines and allows fan and compressor to be set in motion. In modern engines, the bypass airflow is usually responsible for 80% of the thrust.